So let's talk about a pretty huge idea. How do you build a database, your single source of truth, that is, for all intents and purposes, immortal? Today, we're going to walk through how to architect just that. We call it the Eternal Ledger, and it's a system designed to survive just about anything. The source of truth is now immortal. I mean, that's a pretty bold statement, right? But what does it actually mean? Well, it's the ultimate goal of a really smart architectural journey. It means your data foundation is so resilient, so spread out, that it just doesn't matter if a server crashes or a whole data center loses power. Your data just survives. All right, so how do we get there? It's a four-part journey. First, we have to lay the foundation by architecting for pure, rock-solid reliability. Then, we'll take that foundation and scale it up, going from a local setup to a global one. After that, we'll connect all the different pieces, whether they're on-prem or in multiple clouds. And finally, the payoff. We'll see what this incredible setup unleashes. Let's dive in. Okay, part one, architecting for reliability. Before we even think about fancy features or scaling across the planet, we have to start here. This is the absolute bedrock of the whole structure. If this isn't solid, everything else we build is just a house of cards. So what is reliability, really? At its heart, it just means your system does what it's supposed to do, consistently. But here's the trick. You don't achieve it by hoping things won't break. You achieve it by planning for them to break. You build in so much redundancy and fault tolerance that when one piece inevitably fails, the system as a whole just shrugs it off and keeps on going. And to plan for failure, we need the right building blocks. In the cloud, that means zones and regions. Think of it this way. A zone is like a single self-contained building, a data center. If the power goes out in that building, everything inside goes dark. A region, on the other hand, is like a whole city campus made up of multiple independent buildings. If one building has a problem, the rest of the campus just keeps humming along. Spreading your services across multiple zones in a region is like step one for high availability. So we have a reliable foundation. Awesome. Now we can start building on top of it. In part two, we're going to climb what we call the scaling ladder, taking our app from a single spot and stretching its footprint across the entire globe. And this is the ladder. You start on the first rung with a simple zonal deployment. This is great for dev and test, or maybe a small app that isn't mission critical. Then you step up to a regional deployment, using those multiple zones for the high availability we just talked about. And finally, for the really important stuff, you climb all the way to the top, a global deployment that spans multiple regions all over the world. This table really lays it all out. Just look at how the robustness escalates. A zonal deployment can survive a single machine failing, no problem. A regional one, say with Cloud SQL's high availability option, can survive an entire data center going offline. But to withstand a whole region getting knocked out, like by a natural disaster, you need to go global with a database like Spanner. The key takeaway here is to match the level of resilience to how important the application is. Now for part three, where we get into the messy reality of the enterprise world. For most big companies, their data isn't all in one neat little box. It's everywhere, in their own data centers, in one cloud, maybe in a couple of other clouds too. The goal here is to connect all these little islands of data into one unified network, something we call a planetary mesh. But why would you deal with all that complexity? Well, it's usually not a tech decision. It's a business one. Your company acquires another. Boom, now you have two different cloud environments to manage. Or there are data privacy laws that say you have to keep certain data inside a specific country. Or maybe you just want to use a really cool AI service from one provider, but all your data lives with another. These are the real-world reasons for going hybrid and multi-cloud. A classic example is bridging the old and the new. A lot of companies depend on these huge, critical Oracle databases. Migrating them is a massive, risky project. So instead, you can build an Oracle bridge. With new solutions, you can actually run Oracle's own hardware inside a Google data center. This gives you a super fast, low-latency connection that lets you modernize your apps in the cloud while leaving that critical legacy database right where it is. And this is what we're building towards, the planetary mesh. It's way more than just connecting two dots on a map. It's about creating a true hybrid network. Using tech like cross-cloud interconnect, you can stitch everything together into a private, high-speed network. And the result? Your on-prem servers, your Google Cloud services, and anything you have in other clouds, they all just act like they're on one single secure network. And that brings us to the final and honestly the most important part of this whole journey, All of this architecture, the reliability, the global scale, this planetary mesh, it's all been for one single reason: to unlock your data's true potential and power a whole new generation of intelligent apps. So what can you actually do with a setup like this? Well, you can build incredibly powerful generative AI. You can use a technique called RAG, where your databases store something called vector embeddings. Think of it as a way to give the AI a perfect long-term memory of all of your specific business data. Or you can build agentic AI. These are smart agents that can reach out across that entire planetary mesh to automate really complex jobs. Imagine asking a chatbot a question, and it automatically goes and pulls data from 3 different systems to give you one simple, unified answer. That's what this unlocks. So let's step back for a second. What have we actually built here? With this Eternal Ledger, we've created a whole new kind of state for our data. It's now portable, so it can move freely wherever it needs to be. It's consistent because it's managed by globally synchronized databases. And of course, it's unbelievably resilient, built from the ground up to survive failure at every single level. In the end, this whole journey really shows that building things to last requires real intention. Look, anyone can spin up a database for a moment, but it takes deliberate, careful design to build a foundation that can last for an era. Architecture? That's the difference. Stay architected.